Section 9.4 is on arithmetic series. A series is the sum of the terms of a sequence. A finite series has a first and a last term, while an infinite series continues without end. An arithmetic series is a series whose terms form an arithmetic sequence. The sum of a finite arithmetic series is defined as S sub n equals n over 2 times the quantity a sub 1 plus a sub n, where a sub 1 is the first term, a sub n is the nth term, and n is the number of terms. Let's take a look at some examples here. Find the sum of the finite arithmetic series 7 plus 14 plus 21 plus a whole bunch of numbers plus 105. So let's identify some of our parts here. I know that a sub 1 is equal to 7. I don't know what n is. I don't know how many terms are in this series, but I do know that a sub n is equal to 105. And I know that my common difference is 7 because each time I'm adding 7. So let's go ahead and see if we can find n. So using the formula, a sub n equals a sub 1 plus n minus 1 times d. I know that my nth term is 105. My first term is 7 plus n minus 1 times 7. And let's go ahead and subtract that 7. Or actually, I think it's going to work out nicely. I think this is just going to happen that this disappears. Plus 7n minus 7. So 105 equals 7n. So that means that n is equal to 15. Now I can use my sum formula. So S sub n is equal to n over 2 times the first term plus the last term, and plugging that into my calculator, that gives me that the sum of this series is 840. The Greek capital letter sigma, which looks kind of like an E, is used to indicate a sum. This is called summation notation. For example, the series 3 squared plus 4 squared plus 5 squared and so on up to 108 squared can be written like this. With the capital sigma, the number on the bottom indicates the first value of n. So notice if I were to plug n or 3 into here, that would give me my 3 squared. The number on top indicates the last value of n. The explicit formula is this right here out in front of the sigma, and the number of terms in this series is the last value, so 108, minus the first value, 3, plus 1, because whenever you're counting the number of something, you take the largest minus the smallest, and you always add 1. So our example here says, write the arithmetic series 7 plus 9 plus 11, dot, 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 plus 21 in summation notation. So let's go ahead and list what we know. I know that a sub 1 is 7. I know that my common difference is 2. I know that a sub n, my last term, is 21, but I don't know what my n is. So let's go ahead and we can use this to write an explicit formula. So using a sub n equals a sub 1 plus n minus 1 times d. So a sub n equals 7 plus, distribute that 2n minus 2, or a sub n is equal to 2n minus 5. That's going to be my explicit formula that goes out in front of the sigma for summation notation. Now I need to figure out what is my n. Well, I know that my nth term is 21. That's my last term, and that's going to be equal to 2n plus 5. I'm sorry, minus 5. No, it's plus 5. Sorry, that is plus 5. 2n plus 5. Subtracting 5 on each side and dividing by 2, n is equal to 8. Now I have enough information to write this in summation notation. And I'm not the best sigma drawer. Okay, so my first n is going to be 1. Since n goes up to 8, I put an 8 up here, and out in front goes my explicit formula. So that's how you would write that arithmetic series in summation notation. And let's use this notation to find the sum of the finite series that looks like this. So what I need to do is find out what my a sub 1 is. A sub 1 is the value I get when I put my first value of n into there. So 3 times 1 minus 4, or a sub 1 is going to be equal to negative 1. I need to find a sub n, or a sub, and they're actually, this one's kind of easy. Since it starts with 1 and goes up to 10, I know that my n is going to be equal to 10. So a sub 10, I'll go ahead and put that out here. So my a sub n is equal to a sub 10. So that's 3 times, plugging in 10 for n, minus 4. 30 minus 4 gives me 26. And I know that there are 10 terms in this series. Using the formula up above, s sub n equals n over 2 times the first term plus the last term. That's equal to 5 times 25, or the sum of this series is 125. So in this section, we took a look at arithmetic series and how to actually what a series is, and then how to find the sum of a finite arithmetic series.